Dimensional analysis is a method we use to solve problems. It's used in a variety of fields, and we're going to focus on a couple of different ways to use it. The first way is we're going to look at how we convert values among units, so going from inches to feet, from meters to centimeters, from kilograms to grams, and we're also going to use dimensional analysis to solve problems. So dimensional analysis is a really fancy name that just means simply that you've got units, that's the dimension, and then we're going to analyze it. We're going to look at them. So we're going to look at the units, and the units are going to help us solve our problems. So for example, we can say how many inches in 1 foot, how many ounces in 1 pound, and the way we do this is we look at a process. So we read a problem, and the first thing we do is we look at our starting units. What units are given in the problem? What values are given in the problem? And then we're going to look at relationships or conversion factors that help us relate the units we have to the units we want. Sometimes this will be a one-step problem. Sometimes this might be 2 or 3 or even 4 steps. And finally, we'll look for the units we want for our answer. And this is going to help guide the setup of the problem because we're trying to get to a specific unit. And ultimately, we need to ask, does the answer make sense? Is this a reasonable value? For example, if we solved a problem and determined that the weight of a single atom was 47 kilograms, this doesn't seem reasonable. So we've probably got an error in our math. So it's going to take some time for you to understand what's reasonable or not for units that you're not used to, but it is something important to ask yourself every time you solve a problem. Let's look at our first example here. How many inches in 2.6 feet? So the first thing we want to look at is what's given in the problem. So it's asking how many inches in 2.6 feet. So we have two different units here, inches and feet. And we first have to figure out where we're going to start this problem. So because we're only given one numerical value in the problem, 2.6 feet, we're going to start with units of feet. The next thing we have to ask is what units we want for our answer. And the question's very clear. It says how many inches. That's our unknown. That's what we're trying to find. The next thing we have to do is determine what relationships that we might know between feet and inches. Now this is a pretty straightforward example where we have 1 foot equals 12 inches. Sometimes you'll have multiple relationships, and sometimes you might write down a relationship that you don't actually need, and that's okay. You'll also see that some problems, especially multi-step problems, have multiple ways to get from the starting units to the units for the answer. There are multiple strategies that will work for many problems as long as your units work out correctly and you get to the right answer. So let's look at how we actually set up these problems. Now many of you may be able to solve this problem without actually doing any kind of a setup, but I want to show you how we set it up using dimensional analysis so we can take this concept, which is very familiar to you, and then apply it to chemistry concepts or using metric prefixes, systems that are not quite as familiar. So I'm going to start with my 2.6 feet because I said, well, my starting units were feet, so I'll write down 2.6 feet. And then I'm going to set up my parentheses. Now, if you've talked about dimensional analysis before, you may have heard this called the picket fence method, and you may draw something that looks like a little picket fence down here. It doesn't really matter how you draw it out, the concepts are still the same. So here we have feet in the numerator, and I know I want to get rid of feet because I'm trying to get 2 inches, so feet is going to be in the denominator of the next step. So I put the feet in the denominator, and so what I'll be able to see is that eventually those will cancel out with one another. And so this next step, 1 foot, equals 12 inches. The relationship that's written here in the parentheses is true regardless of what value I'm starting with. So when you're putting those relationships or conversion factors in your setup, these values or these relationships in the parentheses are always true regardless of what values you're starting with. These don't change with the numbers given in the problem. Now I can cancel out feet, and I see that I'm left with inches in the numerator, and that's the units I want for my answer. When I plug this into the calculator, I get 31.2 inches. I'm going to round that to 31 inches because of significant figures. A couple of things to notice on this problem is that I always put my units in. So I showed feet in my starting value, I showed inches and feet in my relationship, and I showed units in my answer. Always write your units in. We don't want any orphaned numbers without units. This is because we use the units to solve the problem. And if you don't have the units, it's very easy to invert one of your relationships. The last question we need to ask is, does our answer make sense? So what I want to look at is, what is the inches in 2 feet? What are the inches in 3 feet? And so I see for 2 feet we have 24 inches, for 3 feet we have 36 inches. So if I have 2.6 feet, which is somewhere between 2 and 3 feet, my answer should be somewhere between 24 and 36 inches. And that matches up with what I calculated.